Hello, hello. Are we live? Yep. Welcome back to the advent of syntran. This is day 14. We're more than halfway done with the advent of code. At least in terms of number of days. I think my completion rate might be, what am I, just under 25 stars? I have 24 stars, yeah, so I'm just under halfway through completion, but I'm not going to make it to 100% anyway. So, why are these out of order now? We have 14. Oh, they're going to go back down. That's why we had blank lines here. That's a unconventional layout. Okay, so today we're basically playing 2048. I don't know if you've played that game where like you slide tiles around and then you combine them. We're playing 2048, but without the combinations, but with extra obstacles. So we are given a grid. The grid has dots for empty spaces. It has hashes for immovable cube-shaped rocks. And it has these capital O's. I think they're uppercase O's. Maybe it's a 0, but I think it's an uppercase O for rounded rocks. And the rounded rocks can roll around. So what happens is that the platform gets tilted up so that everything moves towards the north side of the platform. Hey, Kelly. It's nowhere near dinner time, Kelly. Yeah, so they say north, so we're still using that usual cardinal direction convention. They always say north, south, east, and west, as opposed to like up, down, left, and right. At least that seems to be the case for most advent of codes. Callie is right on top of my mouse and she's selecting text. Callie, you might have to go. Twitch stream wants to see me do this puzzle. Can you guys hear the purring? Callie. Usually I get like a solid 30 minutes before she interrupts the stream. Not tonight, though. Okay, Kelly. I'm gonna have to set you down. You're not allowed on the desk. I try to discourage cats on desks, but it's futile. She's gonna hop up here anyway. Yeah, so we tilt the platform and then everything slides north. So here the rocks start out like this, but then after tilting for the test input, they should end up like this. So we have 1, 2, 3, 4 rounded rocks in this first column, and then they all end up at the top of the board. So these rocks, they get hung up on the cube-shaped rock. And if they don't get hung up on any cube-shaped rocks, they get hung up on the northern border or other rounded rocks that are hung up on something else. So it's like the motion rules of 2048, but without the tile combination. I feel good about part 1. I think I can do this. My prediction for part 2 is that they're not just going to make us slide things up, they're going to make us slide things like up and then to the right, or maybe to the left or down, or some sort of multi-directional sliding. I could be wrong. I usually don't get correct predictions for what part 2 is going to be. There's always some kind of twist in part 2. Hey, Kelly. Alright. Kelly. No desk jumping. I also have an automatic downloader, or an input downloader. Not the test input downloader, that's different, but it's over here on the right, but I'll close out there because it's hidden by the chat window anyway. So the trick is to use a Firefox extension to save your cookies. So as long as you have a text file that contains your cookies, then you can use curl and download the input. And the URL for your input is predictable. It's the year 2023 and then the day, so today is 14. So that's the name of your input, and then you can curl that and save it to a local file. The trick is that there's a Firefox extension called cookies.txt. If you try to do this without having your cookies saved, it will tell you you're not logged in, you can't download things. So you have to save your cookies to log in at the command line. For example, now 2023 has all these days. There is no day 14 yet because I haven't started it yet, but let's do that. So this will make a directory for day 14. It will copy my main syntran template into that directory, and then it will also download the input. See, it's curling. It takes a second. Even though it's a small file, network operations, there's a little bit of latency there. So now I can move into that directory, and I have an input file. Hopefully this is non-empty. There it is. We've got a big old grid. This is 100 by 100. So it's not huge. That should be workable. What the automatic input downloader does not do is it does not give me the test input. Maybe if you're an elite hacker, you can just get going directly on the real input and not test your program on the test input at all, but I am not that elite. So let's save the test input, and then I should be able to echo that. There we go. There's the test input. Callie, this is your third and final warning. No desk jumping, please. Got a big old piece of fluff. Callie, you got fluff all over the desk. Okay. So let's start working on this. Let's go to day 14. I think I want to count lines and then pre-allocate the grid. This time I will work with a matrix of characters rather than a vector of strings. I learned my lesson from yesterday. Vector string indexing is too inconsistent to be convenient. Callie, I'm sorry. You've got to go if you're going to keep interrupting. I'm sorry, Callie. All right. So this grid is 10 by 10, I guess. I'm not actually sure. What did I do to my terminal? Okay, so yeah, 10 by 10 with no spaces in here. No delimiters. 10 by 10. Is that correct? Yeah, 10 by 10. Yep. So now that we know the size, we can pre-allocate a matrix of characters, but I don't actually have a character type, so really it's a matrix of strings, and all the strings are going to have a length of 1. I'm going to call it grid. And, So I know I have this issue. When I pass arrays to functions, I have a memory leak in syntran. One way to work around that is to not use functions. A slightly better way to work around that would be to use functions but not pass arrays to them. So instead of passing arrays, I will make my grid array a global variable. So then I don't have to pass it as a function argument, it's just a global variable that all of my functions can access. So I will initialize it it doesn't really matter the size. I guess I can make it 1 by 1. All that has to be right is the type. So this is a string, and the rank. So this is rank 2. It's a 1 by 1 table. I don't know if I can do an empty table. That's probably going to be a syntax error. Or not. I'm not really sure. Okay, so I am allowed to have a 0 by 0 table. So this is just a declaration, really. It allocates it to the wrong size because I don't know the size yet. But now that I've parsed the size out of the file, I can allocate it here, even though it's already declared up above. So now I can allocate it to nx by ny. Those are the dimensions of the grid, or the character matrix. And then I can set each character inside this loop. So y will get incremented every time I read a new line. And then within the line, I will scan across the row in the x direction. That's my usual convention. Y is positive downwards because that's the order that I read the file in, and then x is positive to the right, or for the camera, to the right. Why am I doing if? And this, it's fine. This can be a for loop. I always forget that. So I've read the first line, and then I still want to read at the end of the file, but I don't need to manually increment y anymore. This is just x and y, not ix, iy. So there is our character grid. It has delimiters in between everything, so we have a comma and an extra space in between the actual character payload, but this is the same as this. Looks the same. I think that's right. Okay, now my prediction for part 2 is that they're going to make us slide in multiple directions. So maybe this is overkill. For part 1, you could just hard code it to work with sliding things in the north direction, but I would like to parameterize my directions, and I think I did something similar in day 10. Was it day 10? Yeah, so we have ders, which are east, west, north, and south. These are two-dimensional cardinal directions, and we also have the indices into this array parameterized. So I'm going to copy all of that stuff and reuse it. So for part 1, I'm going to be sliding in the north direction, which is 0, -1. That's also just the negative y direction, because y is positive downwards. That means upwards is north, and it's the negative y direction, not the positive y direction. So how do we slide things north? Well, we're going to have to start iterating from the top row, because if you try to move this one first, for example, you would move this one up. What am I selecting? I don't know how to use tmux. I don't know why there's a selection right there. So if you try to move this up, you can do it by one space, but then what do you do here? Like, there's already another round stone. What are these, stones or rocks? I forget the terminology. But basically you can move this one to here, and then you're stuck because this one hasn't moved. What you have to do is move the top one first, so then this one will go here, and then this one is free to go all the way up here. So you have to iterate in the correct order. Otherwise, if you try to move the bottom stones first, they're not going to move as far as they should. because they'll get hung up on other things that haven't moved yet. So if we're sliding to the north, we have to iterate from low y values to high y values. If we're sliding to the right, we have to iterate from low x to high x. And if it's the opposite of one of those directions, then we have to iterate downwards in a loop. So like if we're sliding things downwards, we have to start iterating from big y values and iterate down towards lower y values when we're just checking for the rocks that need to be moved. So this is a nested for loop to read the grid. But one of my issues in syntran is that I can't do loops with a negative step if I want to iterate in the opposite direction, at least not with a for loop, but I can do that with a while loop. So I'm going to have nested while loops. And then they could iterate in either direction. So we're going to have like an initial y position and a final y position, or begin and end. These will be the defaults, and if we're sliding in the other direction, we'll have to flip these. And the same thing for x. And we also need a delta. So dx is the increment every time we go through the loop. Now, if we're sliding east, we need to do it in the other direction. So first of all, I'm going to parameterize the direction that I'm sliding. So for part one, maybe this is overkill, maybe I don't need to do this, but I'm anticipating what might happen in part two. So the direction that we're sliding is north. So north is that way. If we're doing that, we have to iterate from low y to high y. But if it's the opposite direction, if we're sliding things to the south, then we have to like change all of these values. So in that case, y begin will be ny minus 1, y end it's going to be -1 because it's not going to be inclusive of the end bound. Now, in which case do I need to flip these x values? I have to think about that for a second. So if we have to slide things to the east, then we have to start iterating here and go in this direction. So if it's to the east, we have to start at high x. Are these called rocks or stones? I can't remember. Rocks. Okay. I just want to make my comments consistent with the puzzle input. So that's the reason that we have this flipping logic. I think this is right. Now we need a pair of nested while loops to iterate through these bounds. So while y does not equals y end, I have to be careful here to use not equals, because if I use a less than comparison, it would work for this, but it would be an infinite loop for this, because y is always going to be greater than this. So I have to use not equal as my loop exit condition. And then in here, we're also going to have an X loop. And at the end, it's going to be y plus equals dy. And in here, it's x plus equals dx. Now it will loop in the positive x direction if we're sliding to the west, but if we're sliding to the east, then it's going to loop in the negative x direction. So I just want to make sure I'm looping through everything that I should loop through. We should get 100 lines of output, 0 through 9 in both dimensions. That doesn't work because it's equals instead of equals equals. So I have to initialize these things. Y is still undeclared at 89. Right, let. Okay, so we have 0 up through 9. This is a 0-based indexing system, so it's 0 through 9, not 1 through 10. That looks correct. And y is going in the direction that I want it to. Now, if I change my direction to south instead of north, we should see this go in the other direction. So instead of y starting at 0 and counting up to 9, it should start at 9 and count down to an inclusive of 0. That also looks good. I don't have any off by 1 errors, so I don't start at 10 or anything, or end at 1. That would be incorrect. This looks right. So I want to change that back to north because that's what we're doing, at least for part 1. And maybe this is all overkill. Maybe we're still going to slide to the north for part 2. And it doesn't matter which way I nest these loops, except the grid. It's actually more efficient to access the grid if I have the X loop innermost. Fortran is the same way, because my grid, it has the X dimension here and it has the Y dimension here. So the way that arrays are, the way that 2D arrays are laid out in memory, it's more efficient to iterate through the leftmost dimension in the innermost loop. Leftmost is innermost. That's the mnemonic that I use to remember that. Okay, so inside here, I want to try to move the stone as far north as possible, if there's a round stone there. So if grid xy equals O, first of all, I want to check if that's an uppercase O and not a 0. It's a rock, not a stone. Round rock. They call these round rocks and cube rocks. Rounded rocks and cube-shaped rocks. Well, that's a little bit inconsistent. This is not hyphenated, but this is. Whatever. Okay, so where do we have round rocks? We have a round rock at 2, 9. 2, 9. And 1, 9. That looks right. So if we find one, we're going to want to update the grid. I made grid a global variable so that I could use functions if I want to, but I don't even know if I want to use functions now. So I think I can just update grid in place. I'm trying to think if I want to save like the initial grid and also have like an updated grid, but I think I can just do it in place with one grid matrix. So the initial location of this rock is going to be x naught and y naught. You could use vectors instead of scalars here. You could have one vector. The thing is, I don't have vector addition operations, so it doesn't really save me any lines of code, at least not for a 2D case. For 3D or higher, it would make sense, but for this, it's easiest just to have 2 lines of code for 2 different scalars. Now we're going to slide it in this direction. So it's going to be something from this array, and it's going to be indexed by this value. So this is a 2 by 4 array. And I can just set this outside of the loop. It's dirs. Gonna be 0 idir, because idir is north. We're sliding north for part 1. And this is 1. This is the y value. So 0 is the x value, y is the y value, or 1 is the y value. Now we're going to move this rock as far as we can until it hits something else, or it hits the edge of the map, or the edge of the grid. And to do that, we need to know what the next position would be. So that would be, let's call it xn for x next. That's going to be x naught plus dxs, and then similarly for y. Now we're going to loop until one of these things is out of bounds or until it's not an empty space. So while I'm going to rely on short circuit logic. Yeah, this might crash. I might have to be careful here. Maybe I'll need like a helper function. This is where a function might be useful. Because I want my condition to be basically that this position is in bounds, so 0 is less than xn. This is like the next position. Next candidate position. The rock won't move there if it's already filled up or if it's out of bounds, but this is like the candidate position of where the rock might move. And xn less than nx. And we're going to have similar conditions on y. And this is where it's tricky. this could be an out of bounds array reference. So grid xn yn equals dot. So if these conditions aren't satisfied, this will be out of bounds, but then the while condition should be false anyway. I'm not really sure what will happen. I'm just reading from this location. I'm not writing to it. So I kind of think this might be safe, but it might not be. It might crash, and then I'll need like a helper function to act as this whole condition, which first checks these, and if those are satisfied, then it will try to access this array element. So while that is true, we're gonna sort of repeat all of that stuff. X naught is going to be xn, y naught is going to be yn, and we also have to update the grid itself. So I want to set the current position because there was a rock here, but when we're moving the rock, we have to make this an empty space, and we have to make the next thing the rock. So we're going to update the grid. That will become an empty space. And this will become a rock. I think that's it. And then we'll have to like add up the score. But this moves the grid, but the answer is like we have to add up something depending on which rocks end up in which rows and columns. I forget how that works, but let's just see if we can move the grid for now. So I want to print the initial grid right after I load it. And then print it again. That didn't work. Yeah, so I think this is not good. So I think I want a helper function for this. And instead of doing that, I'm going to say while can slide yeah, this is just going to take xn and yn. And this helper function will just tell us if we can slide a rock into this position. My keyboard inputs just disappeared. That's annoying. These are integers. So first we need to check the bounds, and then if the bound check is satisfied, then we can check the grid contents. I think that should work. So if it's out of bounds, we won't even check this. And that's the point of the helper function. Because you can't really have if logic inside of a while condition. So this thing has to be a function. What did I not declare? NX. Oh. Okay, we'll just add those as args. I think that looks correct. Let's check that. So we have a column of 4 and a column of 3, then 2 singletons, and we have 2 down here. We have this little arrangement, and there's this guy and this guy. 1 here and an empty space, and then 1 more, and I think that's all the rocks. Okay, so now I have to add up the score. Oh, and this is annoying. This is the opposite. It's a 1-based index, and it's the opposite convention as mine. Mine is this row is 0, and this row is 1, and this row is 2. It's like line numbers in a file. It's not y positive up, it's y positive down. But anyway, we have to add these up. So every rock, every rounded rock, yeah, rounded rocks only. We don't have to worry about the cube-shaped rocks, which are the hashes. Every rounded rock gets a score based on the row that it's in. So we get 50 in this row, and then 18 in this row, 2 times 9, and then 4 times 8, and 3 times 7, and we have to add all of those up. And that should be the final answer. That shouldn't be too hard to calculate. Here's another prediction for part 2. Maybe instead of making us slide in a different direction, maybe they'll make us move things gradually. Instead of like sliding everything in one move, have things like slide 1 step at a time. I don't know. I have no idea what part 2 is going to be. I just think it's fun to try to predict it, but I am always wrong. I never know where they're going to go. I think they call it a load. It's like the weight. It's like the moment that the weight of these rocks exert on the platform. But you guys aren't engineers. You probably don't know what a moment is. Or maybe you're an engineer, but you're the wrong kind of engineer. Moment is torque, like foot-pounds, pound-feet, that kind of thing. And for that, we just need to iterate through the grid again. This time we can use for loops again. We don't have to be careful about which direction we iterate. Just have to iterate through everything. If grid x, y equals a rounded rock, then we're going to add up the sum. It's going to be based on y, but not really. It's going to be ny minus y. 10. Yeah. I think that's it. Let me just initialize this lower down where it makes sense. 136. That seemed easy. Where are we at? 40 minutes? I feel like I've been going pretty smooth today. Let's see if this works for the real input. Got a good feeling about this. All right, let's check out part 2. I'm gonna need a break before I fully get into part 2. I knew it! This was my first prediction, that we would have to slide in different directions. How many cycles are we gonna have to do? Now, I hope it's like a manageable number of cycles and not like a trillion. Oh god. That's a billion. A billion. Why does it have to be a billion? Last year we had to simulate a trillion Tetris pieces. The trick was that like you weren't actually supposed to simulate it. You were supposed to like find the cycles, sort of like the ghost map problem from earlier this year. I forget which day it was, but you had to like traverse a graph and move like a ghost, but the ghosts, you had to do something into the billions, but the trick was to notice that there's a periodic cycle, and you don't have to do it everything, you just have to find the period and then kind of extrapolate. So, yeah, is a billion workable? That's a pretty big number. I don't know, will this get into a cycle? And then how can I detect cycles? Those are two tricky problems. I think you could simulate some big number, some big but not a billion huge number, like simulate 1,000 cycles, save that as your state, and then at every cycle after that, see if it matches the 1,000th cycle. Because your initial state is probably never going to recur. It's probably going to take a few cycles to get into a steady state. Hopefully not like more than 1,000. So I think that's how you could do that if you need to check for cycles. But first, let's see like how long this would take to brute force it if we had to brute force it. I think it's probably going to be too slow to be manageable. But like if we can brute force it, just do it the easy way. So let's find out. I have to refill my drink. I have to feed my cat too at some point, but it's not quite time for that. So I need to get her drink and I'll be right back. All right, we are back. So first we have to just do one cycle to see if my direction parameterization actually works. There could be a bug in there, who knows? So I'm gonna take part 1 and copy that to become part 2. It should just run part 1 twice now. And I don't need to print all that junk. Is that still the right answer? 105,982. 105,982, yep. Let me clean up some of this junk. I think I want that. want to actually call part 2. And let's go back to the test input. Okay, that's more manageable. So we get part 1, and then we get the initial grid, and then we get the grid after a north slide. First of all, what order do we do these things in? What is a cycle? A cycle is north, west, south, east. So I want to re-index my directions so that they're in that order. North, west, south, east. North, west, south, east. And then these have to be consistent. So northwest, south, east. That has to be 0, 1, 2, 3. North, west, south, east. I think that's right. So now in my cycle, I can just go through these directions in this order. It's a little bit more convenient that way. Yeah, and we're going to add an extra layer of loops to go through a cycle. First, I'm just going to try one cycle because they show me what that should look like. So here's what it looks like after one cycle. I want to make sure I can reproduce that. So we're going to go through one cycle, and one cycle is 4 directions. So four times n cycle. So one cycle is 4 directions, so that's why this is multiplied by 4. Now I need to close this loop somewhere. I think I want to do it right there, and then print out the grid, and then fix my indentation. And now, IDIR, I'm really glad I set this up right in part 1, otherwise I would just have to do it now anyway. So the direction is going to be II mod 4. Line 26. What did I? Trailing comma. Yeah. I should have a comma there, but not a comma there. Okay, we went north first. Oh, well, we had... Did I just do this in part 1? Yeah, I just edited part 1 instead of doing part 2. I'm just gonna fix that manually. I could like rename this to part 2 and like swap the actual functions, but I think I want to do it the other way. So I need to copy that much and then undo a bunch of, then I have to fix that again too. Well, that's annoying. That's why this was commented out, because this is part 1. I was like, why is that commented out? So I do want to renumber those. Okay, now I need to make sure I edit part 2, not part 1. So right here, we're going to start the cycle iteration. Then all of this needs to be indented, and then I need to fix this again. And I think that's it. What? Oh, I went back to day 10. That's not what I wanted to have open. Let me delete that buffer. BD10. What? Oh, BD3. There we go. Okay, there's part one, and then we do part two, and this is where the cycles happen. So at the initial grid, we slide to the north, and then what is next? West? I guess west is next. Then south, and then east. That should be one cycle. And after one cycle, they say it looks like this. Okay, what's it gonna take to do 1 billion cycles? It's probably not possible to brute force in a reasonable amount of time. Let's see. First of all, I'll need to get rid of most of my prints in here. Is that the only thing I printed? Cool. I want to at least print the cycle index so I can see progress. So that was 4 direction iterations, but 1 cycle. So this is 4 times the cycle index, really. And I want to go up to 1 billion. That. Did that actually? There's no way that did 1 billion. This is part 2, but it's not printing. What the hell is going on? What just happened? Well, it's not the right answer at the very least. I don't think this is. What is going on? My cat really hates it when I stream. Oh, because this overflowed. Yeah. Can I have 64-bit loop iterators? Let's find out. I don't think so. If I do like 1,000, this should work. Because 1,000 won't overflow. Hey, using. I'm working on Advent of Code. Welcome to the stream. Okay, so that's iterating through something. That took 4 seconds, let's call it, for 1,000 cycles. And 1 billion is 1,000,000 thousands. So 4 million seconds is what it would take to do that. What if I turn off the printing? Because the printing takes time. Oh, and we did get to 64. So we didn't have to do 1 billion. It got into a regular pattern after just 1,000. Well, that didn't speed it up that much. It still took 2 seconds. So if I had to do 1,000,000 times more iterations than that, it would take 2 million seconds, which is a pretty long time. 2 million divided by 3,600 seconds per hour That would be like 500 hours. That's like 10 days. I don't know. I've run things at work that take 10 days. I could run an advent of code problem for 10 days. It's not like cryptographically impossible to brute force this. It would just take a very long time. Do I even need to do anything clever? How long does this take on the real input? That takes a little bit longer. Let me put the progress indicator back. I found so satisfying watching somebody programming, even though I don't even know much about it. That's good. Glad you enjoy it. This won't take too long to get to 1,000. But it will take too long to get to 1 billion. And the actual input takes a lot longer to run than the test input, so forget what I said about 500 hours. This would be longer than 500 hours if I brute forced it. But my theory is that this should reach a steady state, where after a certain number of cycles, it will settle into a pattern, and then that pattern will recur. Yeah, so I am working on Advent of Code. This is a series of Christmas-themed programming puzzles, or not really Christmas-themed, but like generic winter holiday-themed. So every day, a new puzzle unlocks. This is December 14th, so we're on the 14th puzzle. And there's a story here that I didn't even read. Like, I reach a place where all of the mirrors are pointing a massive parabolic reflector dish attached to the side of another mountain. So, like, there's a backstory to it. It usually involves, like, elves or snow or something wintry. But really, at the heart of it, it's just a programming puzzle. So we have this grid, and when we tilt this grid, the round things will roll around and everything else will stay where it is. So we have to figure out where these things will move when the grid is tilted. Every puzzle has 2 parts, and these get progressively harder. So like day 1, it's pretty easy. If you've taken like 1 college class on programming, you should be able to do day 1, or the first few days at least. But they do slowly get more difficult. So by day 14, it's starting to get a little difficult. There's also a part 1 and a part 2 for each day. So part 2 is pretty manageable today. But for part 2, they ask us to simulate 1 billion cycles of this tilting in different directions. So that makes it difficult. Oh, this has to go up to 4,000 because it's 4 times the number of cycles. I don't know if I want to let this run, because this is going to take a while longer. Yeah, 3 minutes. I don't want to sit around for another 2 minutes, or however long that takes. So I only want to print on the cycles of 4. Yeah, I think we can add up the score. That's relatively cheap. Okay, so my theory is that at some point the sum should settle down. It should reach a value and maybe not stay at that value for every cycle, but it should recur after some number of cycles. Trying to learn Python. That's cool. CS50 free classes. Yeah, that's good. I think if you pay for programming, you might, if you pay for programming classes or lessons, I don't know, this is controversial. You might be wasting your money. I think there are a lot of very good free resources out there. Yeah, I think it's fun. Some people, they're like forced to take a college class on programming, and like they're really not into it, but I think it's fun. So it's still, okay, it's going back up. It was going down for a while. We were above 100,000. And then it came down into the 90,000s. And now it's kind of oscillating. It goes up for a while and then it comes back down for a while. Let's save this in a file. I want to see if this reaches a steady state. So let's search for this number. That's the only time we found it so far. So will this number come up again? After 200 cycles, do we ever get back to the same state after subsequent cycling? Not yet. If there's a period, it's kind of a long period. Maybe I should have checked this. I only checked my results after one cycle. So maybe I should have verified that I got this right as well. Yeah, I think I should go back to the test input because it's also faster. And if there's a period, I should find the period faster. I still haven't hit any periods yet on this input. Oh. Oh, so we hit 93042 regularly. Yeah, I think this is periodic. I'm learning mainly for making games. I picked Python just because it's easier to learn as a beginner. That's a very good reason to learn Python. Plan to pick up a harder language that will actually be useful for games, but that will be years in the future. Yeah, I think that's reasonable. Yeah, Python is good for beginners. It's one of the first languages that I learned. But I'm not really good at Python, and I don't use it very much these days. It is a good beginner language, though. So we have found some cycles here. So if I search for 93042, we get that, followed by 93068, followed by 93104. And this is 592 cycles in. If I search again, we hit that number again at cycle 728. So 592, 728, and again at 864. So what's the difference between these? Let me split this window. There we go. So 864. Hey, Vision for All. So we hit this at cycle 864, and then we also hit it at 728. So that's a difference of 136 cycles. Now what is 728 minus 592, where we also hit that number? Yeah, so every 136 cycles, we're repeating back to the same state. So that means I don't need to actually simulate a billion cycles. I can just do... When do we first hit this? At 260? Or no, at 592. So I could do like 700 cycles and then extrapolate and say, after a billion steps, I don't need to actually do this. I just know I'm going to get back to whatever state this was. I could probably figure out the answer right now. Python and C, yeah, that's good. Or maybe like C++, I don't know. Everybody you ask is going to have a different opinion about which language you should learn after Python. But I think like C or C++ would be a good choice for games. Okay, so this only did 1,000 cycles or 4,000 steps because there are like 4 different directional steps in one cycle. We can probably figure it out without running anything else. So a billion. I'm gonna have overflow problems. Because it's really 4 times as much as this. After a lot of segmentation faults, try C++. You'll probably manage to get segmentation faults in C++ too. First of all, is 136 divisible by 4? Yes. That's good. I expected that to be divisible by 4. What do I want to do here? Well, really I want 4 billion. So 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 4 billion. 4 billion divided by 136, and floor, this is integer division, so it's whatever that result is rounded down. Use Python cache instead of calculating the cycle. Yeah. I don't know what Python cache is, but I assume it like keeps track of the state and then figures out when you hit that state again somehow. So that's 29 million. Well, that overflows. So I need to manually cast to I64. This is the live syntran interpreter, by the way. I usually don't use this. Okay. Something like memoizing. So I know that I don't get into a steady state until 592. So I don't want to make this too low. But maybe like 10 lower. So I changed that 64 into a 54. So That is some number. And then what is 4 billion minus that? Minus that is 1456. So I think at 1456, I should have the same value that I would have at 1 billion cycles. So 1456, that's not where I wanted to type. So I think this might be the answer. Because if I did this math right, this is, I'm doing 4 billion because I have 4 steps per cycle. So it's 4 billion instead of 1 billion. So this is 4 billion minus some multiple of the cycle period. And that multiple was this, I think. So let me type that out a little bit more clearly. 4 billion minus this times some whole number times the cycle period. The cycle period is 136 steps. But if you do that in cycles, it's that divided by 4. So at 1456, I should have the same sum that I would have after 1 billion cycles. So I think this is the answer. So let me copy that and see if it's right. Maybe am I off by 1? And the answer is too high. Try if it's correct. Yeah, the test puzzle. That's what I should do. I want to save this so that I remember it's too high. So I just get a screen grab of that. Okay. Yeah, so let's test out the same idea on the test input. So let's change this to a 0. That was a lot faster. So what's the answer that we're expecting? For the test input, they say it should be 64. So do I get 64? I get 64 like almost immediately. That doesn't make sense. How do I get 64 here, but I don't have 64 as any of these numbers? Maybe, yeah, maybe this condition is off by 1. So I'll just print every one instead of just the ones that are divisible by 4. Okay. There we go. Yeah, so now we're getting 64 as some of these numbers. Yeah, so it happens at 3999, not at 4000. So maybe I was just off by 1, and then I expected to see this at 1456, and no, I don't see it there. So my math wasn't right. Oh, this might have a different cycle length, though. So what is the cycle length here? Looks like 28. Is my math right? So 140 and 112. 140 minus 112, that's a cycle of 28, and then we should see it again at 68 or 168. So at iteration 168, we have this answer 106 again. So if I extrapolate and try to predict which iteration I need to check, going to be 4 billion, or maybe 399. Maybe that's where my mistake was. Minus 4 billion again, divided by my cycle length is 28. Times 28. Plus some safe multiple of 28. So what is my answer at iteration 584? Yeah, so I need to look at the one right before that. So instead of 584, I need to look at the sum at the step right before that, because I'm just off by one. So if we had, first of all, I wasn't printing all this, I was only printing multiples of 4, so I have to rerun it anyway. Let's change this back to the real input. I think this had to go through like about 500 iterations before it got to a steady state. So we're like halfway there. And what is the math that I need to do here? What was the cycle length? 136. Okay, so I think I should look for 1455, not 1456. And we're only like a third of the way there. I might have it already. I think it's probably at the steady state, but I'm going to let it go for a little bit longer to make sure it gets to a steady state. So I want to wait for 1455. We're like halfway there. It's not too slow. And this is kind of a hack. I'm just assuming that the sum is representative of the whole state, and that's not necessarily true. You could have multiple different arrangements of rocks that add up to the same sum. I'm just assuming that like there aren't any hash collisions, that nothing happens to give me the same sum. Almost there, less than 100 more iterations. Okay. So I think this should be the answer. And remember, they said 93,000, which we tried before, they said that was too high. So I'm expecting something smaller than 93,000, and this passes that test at least. Maybe it is better to group the cycles by 4. Yeah, that's what I did at first, but I got the wrong answer. So like if I only check divisible by 4, I don't get this number, and I know I'm off by 1. So yeah, maybe I should do like if modulo 4 equals 3 instead of if modulo 4 equals 0. Maybe that's what I should have done. But I feel good about this. Let's see. Did I copy the right thing? I don't want to get hit with a timeout again. 85175. 85175. Let's see. All right. Last year I did not know about this trick. Which puzzle was it? Yeah, I have like a summary of all the puzzles on my GitHub. Thanks, Vision for All. What is this? What is this GIF? TwitchCon hype. Cool. So I have a summary of last year's AOC here. Which one used Tetris? Oh, day 17. Yeah. So day 17 asked us to simulate 1 trillion Tetris pieces in 2022. And I only got part 1. Because part 1 was like do some manageable number of pieces. Yeah, basically you have falling, they call it rocks, but basically they're Tetris pieces. Like you have this plus-shaped Tetris piece, and you have like a couple weird non-standard Tetris shapes, but the rules of the game are basically Tetris. Yeah, so what did they ask us to do? After 2022 rocks, that was part 1. So 2022 was manageable to simulate all of that. But then for part 2, they asked for not 1 billion, but 1 trillion. So I actually tried to brute force this, and you know, it just takes forever to run, so you can't do it that way. And I did not know about this periodic cycle trick. But this year I'm prepared, I know about that trick, so I was able to solve this today. I did pretty good too. Only 1 hour and 20 minutes. That's relatively fast for me for an AOC solution. What I should do is like modify my code so that it actually tells me the answer, and I don't have to do this manual math to figure out which step to check and then subtract that from 1. I think I might do that off stream. For now, I will just commit this code. And I also have to feed my cat because she really wants dinner. This is day 14. You remember that puzzle? Yeah. That was one of the few ones last year where I didn't get part 2. Yeah, let's verify that that pushed. All right. Here's the input. Here's the code that we wrote. Did I need this to be a global variable? Yeah, because the can slide function takes that as a variable. If I passed that as an argument, I probably would have had a memory leak, which would have stopped me from being able to solve this. So unfortunately, I did have to fall back on using global variables just as a workaround for really nasty memory leaks in syntran. Part 1. And part 2, I'll need to clean up part 2 after the fact so that it actually prints the answer and you don't have to guess about the cycle period. Yeah, I think that's it for today. I will catch you next time.